So this is our Unit 4, Lesson 3, factoring using quadratic form. We're going to be working on is factoring higher degree polynomials that can be written in a quadratic formula, or form, sorry. We'll take a look at in another unit what to do if you can't use this method of how to factor higher degree polynomials. But for right now, this is what we're going to take a look at. Okay, so here's our first problem. We have x to the fourth minus 2x squared minus 8. So if you look at that, okay, we have an x to the fourth. So we haven't factored those before. We factored quadratics, and now the highest thing we've looked at is perfect cubes. So an x to the third, or even an x to the sixth, or whatever. This is a trinomial that has an x to the fourth in it. But if you notice, it's following the same pattern that a quadratic does. Okay, that pattern I'm looking for is the fact that I have variable, variable, no variable in my last term. Okay. Now, if I notice the middle variable, the one is 1/2 of the original. So this can work. Okay, I can use this quadratic technique in order to help me. So all we're going to do is for right now, okay, there's a couple of different ways you can think about this, but for right now, we're just going to replace our x squared with something else. Okay, so a, all right, or you can just leave it as an x. It really doesn't matter. But for right now, I'm going to take this quadratic, or this pattern, I'm going to drop it down to a quadratic. Okay, so if you notice, I took a factor of x squared out of those first two ones. I changed it to something I know. And now I can factor using whatever technique I want. The box, grouping, or since my coefficient here is a 1, I can just go ahead and say, oh, okay, two numbers that multiply to -8 and add up to -2, or -4 and a +2. Okay, so now if I were to multiply that back out, I'm going to get back to this original one, but I'm not going to get back to the x to the fourth. So remember, I replaced my x with an x squared, so I need to go back through and put it back in. So I have x squared minus 4 and x squared plus 2. Okay, and you can kind of do a quick mental check to make sure that works, because x squared times x squared is x to the fourth. All right, and then when I keep foiling it out, x squared is my middle term. All right, now got to be careful here because technically I'm not done. This is a difference of perfect squares, so that one can be factored further. All right, so I have x minus 2 times x plus 2. So you do always have to look at in the problem. It doesn't show that point, but get in the habit of making sure you are as completely done as possible. All right, so the way that it's written over here is saying, okay, replace that with a different letter, doing the same thing. Replace x squared with a. So that means I have a squared, because that's saying I have 2x squareds, right? 2a's or 2x squareds, whichever way I want to think about it, but kind of breaking it down. So as long as the middle variable is 1/2 of the first variable with the exponent, you can still use those quadratic techniques, okay? All right, so look at this one. This looks kind of ugly. But notice, guys, it's a difference of perfect squares. What is the square root of 4x to the fourth? It's 2x squared. The square root of 8 minus x squared is 8 minus x. So this is a difference of perfect squares. So I can either rewrite it substituting things in, or I can just realize, hey, I'm just going to take the square root of each using my difference of squares pattern. Okay, so it's kind of already worked out over here, but let's talk through what's going on. So the square root of 4x to the fourth is 2x squared, right? The square root of 4 is 4. The square root of x to the fourth is x squared. Plus the square root of that is 8 minus x. And we can keep that in parentheses for now, the 8 minus x, okay? We'll take them out in a moment. In my second one, it's going to be the square root minus the square root. So 2x squared minus 8 minus x. And the reason I kept it in parentheses is mainly because of this minus over here. On this side, it doesn't matter. I have 2x squared plus 8 minus x. And I probably want to rewrite that so it's in our typical polynomial form where we're going from the highest exponent down to the lowest. But over here, I have to be careful because I'm distributing this negative through. So that's the one that really I got to be careful about. I've got 2x squared plus x minus 8, right? Because that became a -8 and a positive x. And then, of course, check to see if you can factor further. 2 times 8 is 16. Are there any factor pairs of 16 that add up to -1? No. And then on my other one as well. So looking at this, I saw I had a 4x to the fourth, and I can say, okay, that's still a difference of perfect squares. Anything squared, the square root is just going to be to get rid of that exponent. All right, so we've got to start looking for things like that. If it looks ugly, look for patterns we already know. Can I factor it like a quadratic and then just substitute something back in? Is there a difference of squares? Maybe it's just not the type of perfect squares I'm used to looking for. All right, so a couple for you to try on your own, okay? Give them a try and then go back through and I'll actually explain what I'm doing as I walk through. So I'm not going to pause the video. I'm going to keep going, but I want you to pause the video and see if you can try any of these, if you can figure it out, okay? So pause the video. All right, welcome back. So this first one, I have x to the fourth plus 7x squared plus 6. So I notice that my middle is 1/2 for the variable of the first term. So I'm going to go ahead and try my quadratic technique. So once again, subbed a in place of x squared. Okay, you can do that, or you can just realize that, if I cut down my variables now, I can replace them later. But this is why it's able to work, because this is x squared, right, or a squared, whatever. So now I can factor this. So I need two numbers that multiply to 6 and add up to 7. Okay, well, that's going to be 6 and 1. All right, and I'm going to replace the x squared back in place of the a. So I've got x squared plus 6, x squared plus 1. And of course, we can go through and multiply it back out to check. And I can't factor anything further. All right, so as long as it's 3 terms and the middle term is half of the first term in terms of exponents, I can use the same quadratic techniques, okay? All right, my second one, same thing, it's a trinomial. X squared is half of x to the fourth. So I can go ahead and replace this. I can say a is going to be x squared. So that means I have a squared here minus 3a minus 10. So two numbers that multiply to -10 that add up to -3. A minus 5 and a plus 2. And then just go back and put my x squared in there. So it's not that I'm changing the problem, I'm just writing it when I'm replacing the x squared with an a. I'm just writing in a way that we're familiar to seeing, okay, and it will work out. None of those can be factored further. All right, in my next example, we can put a in place of x squared again. So I've got a squared, right, because I have a squared, so it's really x squared squared, plus 11a plus 18. Two numbers that multiply to 18 and add up to 11 are, of course, 9 and 2. Sorry, I didn't mean to put that there. So I have x squared plus 9 and x squared plus 2. Can either of those be factored further? No. Yes, x squared and 9 are perfect squares, but that's a plus, not a minus, so I can't do it. All right, looking at my next chunk. Okay, I see an x to the fourth again, so looks kind of scary. But guys, notice it's 2 terms, really, with a minus sign. Is x to the fourth a perfect square? Yes. Is 2x minus 5 squared a perfect square? Yes. Anything with a squared outside of it is a perfect square. All right, so the square root of x to the fourth is x squared. Put a minus and put a plus. The square root of this squared is just the 2x minus 5. All right, and now I can write it. X squared minus 2x plus 5. X squared plus 2x minus 5. And can either of those be factored further? That's all I can do. All right, same thing over here. I've got difference of perfect squares. 16 is a perfect square, and so is this. Square root of 16 is 4. Minus and a plus. X plus 7. X plus 7. All right, so I've got 4 minus x minus 7. 4 plus x plus 7. And I can simplify, combine your like terms. Okay, so in this one, I'm ending up with -x minus 3. Let me extend the page 1 second. All right, I got that from 4 minus 7. And here I end up with x plus 11. Can I do anything? Yeah, notice, guys, I have a negative here I need to take out. They have a GCF of a negative. So that's my final answer. So if I were to multiply all that through, at first it wouldn't look the same, but if I were to simplify this by foiling the x plus 7, distributing my negative, and combining the 16, you will get back to that. You should. All right, my last one, two terms. It's not a minus sign, so I can't look for squares, but if you notice, I have perfect cubes. So I'm going to go ahead and use my pattern, which is a binomial times a trinomial. It's a plus, so I have plus, minus, plus. Cube root of 64x to the third is 4x. Cube root of 25 is 5. The 4x squared is 16x squared. Multiply them together, giving me 20x. 5 squared is 25. And that's as far as I can go. All right, so we have to use our quadratic techniques and our difference of squares for some funky looking things to factor. All right, but we can do it. And that is the end.